Okay, so one thing I want to start off by showing you is one of the warm-up problems, actually the first two warm-up problems we did that were just simplifying with exponents. We got the right answer for this one, but at first the person came up here, they said, would this be 10 to the 6th? Okay? And that was because you didn't take the time to write it all out. If you write this out, though, this is 5 times 5 times 5, and this is 2 times 2 times 2. So can you see how we could have rearranged it and thought of it as 5 times 2 times 5 times 2 times 5 times 2? So what does that actually equal to then? 10 to the what? Thirds, because there's a 10, 10, and 10. So this is 10 to the third. So what that tells us is that if these exponents are the same, we multiply the bases and we keep the exponent the same. So that's 10 to the third. The same thing was true here. This was 2 times 2. We had it as a factor 4 times. Here we had it as a factor 4 times with the 3. So what's this actually equal to then? 6 to the 4th. Okay? So if you'll ever forget these rules, you just want to kind of write it out and just develop the rules again. It's not a big deal. Okay, this was one of our warm-up problems, and we just multiplied the whole thing out by the way that we knew, by distributing. But what I was talking about is there was a mathematician named Pascal who came up with a triangle that can help us with binomial expansion. Here's what he said. He said if we have a plus b to the 0 power, what's anything to the 0 power? 1. So then he said, what if we had a plus b to the first? Okay, well that ends up just being a plus b. So the coefficients are 1 and 1. Okay, so then he was just trying to figure out the coefficients for these types of problems. And here's what he noticed. If we have a plus b squared, the coefficients are 1, and then it's 2, and then it's 1. Look at the pattern. We bring the 1 down, we bring the 1 down. 1 plus 1 is 2. Then he noticed this. If we have a plus b to the third, this actually, if I multiplied it all out, it would end up being a to the third plus 3a squared b plus 3ab squared plus b to the third. He multiplied the whole thing out and he noticed this. What are the coefficients? One, 3, 3, 1. Look at that pattern. Bring down the 1. 1 plus 2 is 3. 2 plus 1 is 3. Bring down the 1. So it continued like this. He did a plus b to the 4th. The coefficients ended up being 1, 4, 6, 4, 1. A plus b to the 5th. He figured that out. That was a 1, 5, 10, 10, 5, 1. Can you see what I'm doing there to develop this triangle? So how that helped him was because he could expand this so quickly now. Here's the way this would end up expanding. Watch, I'm going to do it pretty slowly. It's 1a to the 5th plus 5a to the 4th b plus 10a to the 3rd b squared plus 10, look what's happening to the a's. A to the 5th, A to the 4th, A to the 3rd, what do you think the next one is? A to the 2nd, look at the B's. No B, B to the 1st, B to the 2nd, what do you think it's going to be? B to the 3rd. Can anybody tell me what the next term's going to be then? 5 what? A, B to the 4th, good. And then my last term is going to be plus 1. And what do you think it's going to be? B to the 5th, good. And that's how we would expand that. Isn't that so much faster than doing a plus b times a plus b times, can you imagine foiling all that out? It would take us forever. So we can kind of thank those early mathematicians for these kind of shortcut things that we get. So now back to this problem. How does it help us on this problem? Well, here's how it helps us. By looking at this, we knew this right here, okay? So I now identify that my A is going to be X and my B is going to be 3. And I can just plug it into this formula now. So it's going to be, my a is x, so it's going to be x to the third. Let's go to my next one. Plus 3, here's my a, x squared, times my b, which is 3, plus 3, here's my a, is x, times b squared, b is 3, square it, plus, take your b and cube it. So look what this ends up being then. We have x to the third, plus, this is 3 times 3 is 9x squared. Here we've got 3 squared is 9, times 3 is 27x, and 3 to the third is 27. That's the same thing we got earlier. Remember, we got that same answer earlier when we multiplied it all out. So it's going to be a big time saver. Okay, so now let's do that other warm-up. Well, let's just do one a little different. Let's do this. What about if we're doing 2x minus 3, let's do it to the 4th power now. You might want to write this down in your notes section. You can watch. If it helps you more just to watch and listen, I'm fine with that. Whatever's best for you. Alright, so we're doing this to the 4th power. So I'm going to be wanting to use this right here. And I'm going to have to use that, and I'm going to have to write it out. So here's how the pattern's going to go. 1a to the 4th plus. The next one, Drew, what's it going to be?
4a to the 3rd.
Careful. Look at the pattern. A to the 4th, a to the 3rd, just b to the 1st. See, these exponents for each term have to add up to be the 4. Okay? And Kayla, what about the next term? Right. Tyler, what about the next one? Okay, I'm just wanting to do it in terms of a and b right now, though. So 4 times, right? And then the last one's going to be just what, Grace? Just 1 times, right? Okay, so now I'm going to identify it. Now, look at the form, though, we have to have. It has to be a plus b. So I'm going to have to think of this as 2x plus negative 3 to the 4th to use my formula. So a is going to be 2x, b is going to be negative 3. And now it's just a matter of plugging it into this. So I'm going to get 2x to the 4th plus 4a to the 3rd times b plus 6a squared b squared plus 4a b to the 3rd plus 1b to the 4th. And now I just simplify. 2x to the 4th is 16x to the 4th. This is going to be 2 to the 3rd is 8. 8 times 3 is 24. 24 times 4 is what, 96? So it's going to be minus 96x to the 3rd. My next one, I'm going to have negative 3 squared. That's a positive 9. 9 times, well, I got to square my 2. So I'm going to have 9 times 4 is 36 times 6. And it's going to be 216, and it's going to be positive. My next one, negative 3 to the 3rd is negative 27. So I have times 8. Let's see, that's going to be 200 plus what? Is that, what is that? 27 times 8, guys. What's that going to give us? 216 again. Yep, that's right. So we're going to have minus 216x. And then on my last one, negative 3 to the 4th. Well, 3 times, see, look, guys, you can just do this. So this is 9 times 9, so it's just 81. So there's our answer right there. Okay? Now, here's a typical problem that is always on, it's always on these contests. Like if you decide to get into mu alpha theta, there's always a question like this. They'll say, what is the fifth term of, say, x minus 4 to the 7th? Well, if you sat here and raised that to the 7th power, it would take you probably 20 minutes to do one problem, and there's about 30 questions on these things. So what I would want to do is I'd quickly go through. Here's what I do, guys. I'd say, there's to the 0 power, there's to the 1st, here's to the 2nd, to the 3rd, to the 4th, to the 5th, to the 6th, and to the 7th. So you see what I'm doing? I'm just creating Pascal's triangle. We're trying to find the 5th term. So here would be the 1st, 2nd, 3rd, 4th. Here's the 5th term right here. So I know the 5th term then is going to have to be 35. This would be a to the 7th, a to the 6th, a to the 5th, a to the 4th, a to the 3rd. B would have to be to the 4th because these always have to add up to be whatever that is. So here's my A would be x, B would be negative 4. So to figure this out, I could just do 35 x to the 3rd times negative 4 to the 4th, and then I can just get out a calculator. So it's just going to be 35 times, I don't even need the negative because the negative to the 4th is going to be a positive, 4 to the 4th, and I get 8960. So that term would be 8960 x to the 3rd. See? You can do that, right? Any questions? You guys feel like you could do this? All right. So we have a worksheet to do, and rather than going over the homework, I want you to work on this worksheet for the rest of the time because that's going to be the last thing we do. Tomorrow and Wednesday we'll be doing exam reviews in class and working together and asking questions. So remind me tomorrow to make sure we do go over the homework, the one you're doing today and yesterday. Those will be your final points for the quarter.